Hey, so you couldn't resist, eh? You clicked on this video, and of course, you are expecting an answer to that question in your head, to that little spark of curiosity that just lit up inside you. Well, no, I'm not giving it to you. I'm not here to hold your hand. I'd rather take you along for the ride, and for that, what better way to start than with a story? Our story takes place right here on Earth, starring three main characters: a Swiss French inventor, a Belgian Catholic priest, and an Italian pope. It's 1951, and back then, the world situation was complicated to say the least. Think about it. Just 6 years later, World War II was still raging. The world is split into two rival groups that absolutely hate each other. The arms race and the atomic bomb. Humanity seems closer than ever to destroying itself. But there's still a bit of hope. Europe is slowly rebuilding. The United States has never been more powerful. Germany is in ruins, and colonized countries are dreaming of independence. Jazz is at its peak, and in its shadow, rock music is just starting to take its first step. It's in this tense, emotional world that our first character enters the stage, Pope Pius XII. In 1951, during a speech at the Pontifical Academy of Sciences, he claims that science has proven the existence of God. But what scientific discovery could make him say something like that? To understand, we need to go back 40 years to 1950. A young researcher who just a few years earlier was still working on machine and patent application has just published a scientific paper that will shake the world, maybe even the whole universe. It won't be his only paper, far from here. But this one will change physics forever. That researcher's name? Albert Einstein. The theory of general relativity. What is it? To put it simply, gravity. You know, that thing that keeps our feet on the ground. But can we really call gravity a force? Well, not, since Einstein came along with his theory, sweeping away Newton's old ideas about gravitation. Alright, let's keep it simple. Friends ready? Here is general relativity, explained in 30 seconds. In Einstein's theory, gravity is not a force, it's an effect. More precisely, it's the curvature of space-time. Picture all units, meaning distances and duration, as a huge stretched-out sheet. If you put a heavy object, like a planet or star, it bends, placing a bowling ball on a blanket. Now, if you hold a tennis ball across it, the ball will be pulled toward the jeep and will spin around it, and eventually falling. That is exactly what we see in our solar system, and even with the moon. With this theory, Einstein did not just change theoretical physics, he shook the scientific world and merged space and time into a flexible, bendable, four-dimensional structure. But what does that have to do with the Persian priest and God? Hold up, we are getting there. Now, it's time to bring in our final main character, the Belgian astrophysicist, Georges Lemaitre. Einstein's general relativity gave the world his famous equation for the gravitational field. By studying them, by looking at how they describe the evolution of the universe, Lemaitre, in 1927, decided to follow the thread of the eternity backward to figure out the origin of the cosmos. And that's why we get the Big Bang. The Big Bang, most people think they know what it is. A giant explosion 30.8 billion years ago that supposedly created everything. But in reality, that idea is wrong. The Big Bang was not an explosion at all. It was more like a rapid expansion of a teeny, incredibly dense field, no bigger than the hair of a pin. And now, do you see where I'm going with this? Your connection to God. Still nothing? Alright, let me explain. The Big Bang Theory tells us there was a time when our entire universe, vast and complex, was squeezed into an infinitely small space where all matter was compressed to the extreme where unimaginable heat reigned. Then, one day, this universe expanded. That is the expansion. From this expansion came atoms, stars, galaxies, planets, humans, and light. From that origin battle between matter and antimatter, light and darkness, it was light that won. How can you not see the parallel with the famous fiat lux from the Bible? That moment when God said, "Let there be light." Light was born from the universe expansion. Sound convincing, right? Well, maybe not, because even though the Big Bang marks the start of our observable universe, nothing proves that there was nothing before. In reality, we can see past that 0 point. Light didn't exist yet, and as for Lemaitre himself, he believed that linking science and faith was a mistake. For him, cosmology was not about proving religious or philosophical ideas. Its only goal was to realistically and currently describe our observation of the world. But if you really think about it, saying that something as vast as the universe wants to fit into something so tiny, it makes you pause, doesn't it? From that minuscule point came everything that exists, and every part of the universe seems to carry a trace of that original moment. And what if I told you that we living beings also carry a representation of that original code inside us? Let me introduce you to DNA. From the smallest unicellular organisms to multicellular beings like you and me, one thing connects us all: this microscopic double helix. Take this virus, for example, SRS, also known as a coronavirus, and you. If we unravel your chromosomes to assess your DNA, you'll find in both the same bases: thymine, cytosine, guanine, and adenine. DNA is a universal genetic language, a shared code that touches life. It connects us at our deepest level as clusters of cells, vibrations of the same original program. If you're watching this video right now, you are obviously on YouTube. Look at your address bar. You probably see something like this. And that 3W, you know what it means, right? Sure, everyone knows it's the World Wide Web, but did you know there's another 3W? Not a virtual web, but a natural, much older one, the World Wide Web. So, what's the World Wide Web? It's basically an interconnected network, a bit like the internet, but made of trees and fungi. This network is vital for trees. It allows them to communicate, exchange nutrients, send warning signals, and even protect each other. Imagine it as a giant plant nervous system. So, how does it all work? Thanks to mycorrhizae. These are symbiotic partnership between a tree's root and fungal filament, basically mushrooms. The deal is simple. The tree provides carbohydrate from photosynthesis, and the fungus helps the tree absorb water and nutrients from the soil, like nitrogen and phosphorus. And these mycelium filaments can spread for dozens of kilometers. They form a true underground network, linking an entire forest, a kind of plant internet. Fascinating, right? Give to receive. A beautiful life lesson from the living world. Unless, well, you will see it's not always the case. Earlier, we saw how trees and fungi work together to grow. That's called symbiosis, more precisely mutualism. A relationship where both partners benefit. But there are two other types of symbiotic relationships. First, there is commensalism, like between these whales and those barnacles. Barnacles are small crustaceans that love to attach themselves to whales or sea turtles. Once attached, they travel with their host to plankton-rich whales, which they feed on. They basically use the whale as a moving purse without harming it. Then there is parasitism, which is nothing like a peaceful coexistence. Here, one benefits at the expense of the other, which can suffer serious harm. Sometimes the host survives but remains weakened for life. Other times, the parasite drains it completely, leading to a certain death. Examples include tapeworms in neurons or certain parasitic arthropods that attack clownfish. Fascinating, right? Yes, nature is fascinating. All these species, all these type of relationships, it is as if we are all part of one whole and indivisible living being that evolves. Something like a tree, perhaps. And also, speaking of which, have you ever heard of the tree of life? No? Well, it's a gigantic family tree that connects every living thing, from the tiniest flea to the massive deep sea squid. All life is mapped out here. It's really a tool that helps us understand how life has evolved into what it is today. A family tree looks something like this. I know it might seem intimidating at first, but you will see it's much simpler than it looks. Picture the branches of a tree. Imagine the leaf at the end of each branch. Here, each leaf represents a living species or one that has gone extinct. The point where two branches meet show a common ancestor. Take mammals, for example. On this tree, you will see that the shared branch connects primates like humans and rodents. That means they had the same ancestor before their evolutionary path split. And following that logic, we discover some surprising things, like a toad is more closely related to a human than to a shark. A crocodile is closer to a chicken than to a lizard. In the end, we are all part of one huge living family, united by the shared evolutionary tree. So yes, you and that little Japanese macaque are cousins, which might explain why they can yawn just like us. Hmm, yawning. Strange little action when you think about it, isn't it? But have you ever wondered why we yawn? Well, to put it simply, is to wake up our brain, to give it a little boost. That's why we yawn a lot when we wake up, or when we are very tired. But here's the wild part. This small, seemingly harmless action is contagious. Try it. Tell me in the comment how many of you start yawning while watching this video. And that's perfectly normal. Because this contagion, more specifically this imitation-based contagion, comes from something neuroscientists call mirror neurons. As humans, we have billions of neurons in our brain, and among them, there is a special category capable of mirroring almost any action we see another human do. They are so powerful they can even activate when we imagine ourselves doing something. These neurons play a huge role in learning, coordination, and also in our emotional and social lives. They are the reason we can put yourself in someone else's shoes, understand their feelings, and feel empathy. Humans are social animals. We need to connect with others, to share emotions. Mirror neurons are like invisible threads that connect almost all of us to one another. And speaking of connections, have you ever fallen in love? Felt so deep emotion for someone that you could almost sense exactly what they were experiencing, as if their emotion state affected you. Like your souls, your thought, your choices were somehow linked. Well, what if I told you that something similar happened, but between twins? Meet the James twins. James Lewis and James Springer were monozygotic twins, meaning they came from the same egg, but were separated shortly after birth. They finally met again at the age of 39 in 1971 as part of the famous Minnesota twin family study. And let me tell you that the researchers were stunned when they learned their story. In fact, these two brothers, separated at birth, had led nearly identical lives. Both had been married twice to women with the same first name. They each had a dog named Toy. They were exactly the same height, 6 feet, and weighed the same, 180 pounds. They drove the same brand of car, loved the same school subject, and even had similar difficulties with writing. This fact, which seems almost unbelievable, is in some ways symbolically similar to a concept in quantum physics called entanglement. So, what is quantum entanglement? It's an extraordinary phenomenon. Imagine two particles, A and B, created together and then separated by an immense distance. If you change the state of particle A, particle B reacts immediately, as if they were still connected. Even if particle B is on the other side of the universe, it is instantly affected. Hard to believe, right? Even one of the scientists behind his discovery didn't fully believe it himself. This phenomenon was theorized in 1935 by Einstein, Podolsky, and Rosen. Einstein himself, despite co-authoring it, remained skeptical. As you may know, Einstein, the greatest genius of this century, was born in Germany. He later renounced his German citizenship, becoming stateless. Then he obtained Swiss and later American nationality. And I'm pretty sure that if you look far enough back, we had find some of his ancestors who came from territories of the Holy Roman Empire, an empire that saw itself as a legitimate heir of the Roman Empire. In fact, the fall of the Eastern Roman Empire is often considered one of the key events marking the end of the Middle Ages and the start of the Renaissance. What? You don't know the story? Well, let me tell you about it. We are in 1453, May 29th to be precise. A date that would forever change the course of European history. On that day, Constantinople, the great capital of the illustrious Byzantine Empire, fell into the hands of the Ottomans, led by a young sultan of only 21 years old, Mehmed II. The fall of Constantinople may seem distant or insignificant to us today, and yet it will alter the destiny of the West in the years that followed. But first, some context. By this time, the Byzantine Empire was old, and its capital was in full decline. Still, even in these troubled times, Constantinople remained a strategic crossroad between Europe, Asia, the Mediterranean Sea, and the Black Sea. You see, Constantinople partly controlled the trade route for silk spices and precious stone coming from Asia via the famous Silk Road. For centuries, Venetian and Genoese merchants passed through it to reach the Orient. But when the city fell, it marked the end of the last Christian stronghold in the East in the face of Islam expansion, now at the very gates of Europe. Given the dense relation between Muslims and Christians in the Middle Ages, one might ask, why did not the Christian kingdom of the West send troops to defend their borders in Constantinople? Well, the truth is, although Constantinople was indeed Christian, it was on the wrong side, it was Orthodox. And for many Catholic kings in Europe, Orthodox Christians were seen as heretics. Add to that a Europe weakened and divided by the Hundred Years' War, and you have the perfect scenario from film in which Constantinople stood no chance. Yes, a few Genoese and Venetian mercenaries came to help, but it was far from enough. The city weakened, isolated, and poorly equipped, could not hope to resist the 80,000 Ottoman soldiers and many fearsome Janissaries. So it's no surprise that after 50 days of siege, the city finally surrendered. The consequences were immediate. The fall of an empire more than 1,000 years old did not go unnoticed. First came the rebranding. The city's name changed from Constantinople to Istanbul. Then came the end of the free trade between Europe and Asia. The eastern trade routes became nearly inaccessible to Europeans. Trade with Asia became more expensive, more dangerous, and far more complicated. The result? European explorers began searching for new ways to reach the Orient by sailing around Africa or heading west. For the city's Christians, the situation was far from ideal. Two, Mehmed allowed them to continue Christian worship and ceremonies, but since the fall of the Paleologos dynasty, many no longer felt safe. Byzantine scholars fled to Venice, Florence, and Rome, carrying with them Greek and Roman manuscripts long forgotten in the West. And thus began the Italian Renaissance, with names like Leonardo da Vinci, Michelangelo, and Donatello. Everything followed quickly, making this small accident, the fall of Constantinople, the trigger that completely reshaped the geopolitical history of Europe. The beginning of the great age of exploration, with names like Christopher Columbus, Vasco da Gama, the birth of globalization. Crazy, right? The fall of an empire dragging with it the end of one world, only to see another, even greater, rise from its ashes. But If there is one we must not forget, it's the next one. A major event that forever changed our relationship with knowledge. In the Middle Ages, passing on knowledge was a very slow and difficult process. Why? Because everything depended on handwriting manuscript. For a long time, these copies were made in monasteries by specialized monks. But starting in the 14th century, the demand for books exploded, and this copying workshop could not keep up. First, you should know that early books were written on parchment, made from sheep or calf skins. It was an expensive and hard to produce material. To create printing, three things were needed. First, a flat, cheap material where text could be printed. Second, a machine that would press the paper hard enough to reveal the letters. And finally, a set of movable metal type characters. And this is where a German goldsmith named Johannes Gutenberg comes in. Gutenberg managed to bring these two key elements together to invent what would later become modern printing. With this combination, he created the first movable type printing press, and around 1455 printed his famous Bible. This invention, which seems simple to us today, completely revolutionized book reproduction, democratized access to knowledge, and changed the history of thought in the West forever. For the first time in history, knowledge became reproducible, accessible, and widely shareable. It was the end of the church monopoly on writing books and the beginning of a new era. And then came the Reformation. Among those who took advantage of this invention was the German monk Martin Luther. In 1517, Luther nailed his 95 theses to the door of a church, criticizing the Catholic Church and its scandalous trade in indulgences, a system that allowed anyone who could pay to buy their place in heaven. Thanks to the printing press, his text spread like wildfire across Europe. It was the start of the Protestant Reformation. But religious tension grew. Protestants were persecuted in many Catholic countries. Many fled to newly discovered land across the Atlantic. And that is how, in part, the conquest of the New World began. Speaking of the New World, that is America. Do you know that the famous American Revolution actually caused the fall of the kingdom that supported it? Yes, it's pretty wild. On July 4th, 1776, the North American colonies declared their independence from England. It was a clear message to the British monarchy. A new free nation no longer wanted to live under British rule. This American victory against one of the world's greatest powers at the time, the former American colonies proved to the world that it was possible to overthrow monarchies and establish a trustworthy republic. But this revolution didn't happen on its own. It was largely supported by France, which invested a huge sum of money. As a result, France, already in economic crisis, was left bankrupt from helping the Americans. And it was in this context of extreme poverty, social inequality, and a monarchy disconnected from reality that evolutionary ideas crossed the Atlantic, igniting the monarchy of Louis XVI and eventually leading to the French Revolution of 1789, with its countless beheadings. So let's talk about aristocracy. But before that, what does aristocracy really mean? Aristocracy is a political system like democracy, but where power is officially held by a small dominant elite. This elite is not always just nobles or rich people. It could be a caste or even an intellectual or philosophical elite. Already present in ancient Rome, aristocracy really took shape in the Middle Ages, becoming a fully organized system based on feudalism. So to put it simply, the heart of this feudal system is land, and here is how it works. In a feudal system, a lord, whether a king or a noble, grants land to a vassal who in return submits to his authority. But in fact, does this land really belong to the vassal? Of course, no. As you might guess, the vassal only manages the land given by the lord he pledged loyalty to. The lord is the true owner of the land and everything on it, crops and peasants alike. The peasants are exploited with no real freedom or protection. This system worked well for the nobility until 1347, when the Black Death struck Europe. And it was merciless. In less than 8 years, it killed more than half of Europe's population, becoming one of the worst pandemics in human history. And then everything changed. By killing so many people, the Black Death also destroyed a huge part of the active workforce that the nobility relied on to work the fields. Survivors who had witnessed the horror of the plague began demanding better conditions, ending the feudal system. This led to the rise of new cities and a new class, the bourgeoisie, who centuries later would lead modern revolution and behead monarchies across Europe. Mathematics. A student change of topic, maybe. But admit it, we all roughly know what math is, a subject we have all encountered, and some quickly labeled as their enemy. Yet, if this discipline is so important, maybe it's because it's literally everywhere. Didn't Galileo say centuries ago that the universe is written in the language of mathematics? And what if that was not just a poetic phrase? What if it was literally true? Let's take an example everyone knows. Pi. What is pi? Simply the relation between the circumference of a circle and its diameter. It appears in all geometric calculations related to circles. But not only that. In fact, pi is at the heart of everything periodic. Vibration. electrical signals, and even your heartbeat. Why? Because all these phenomena can be mathematically modeled using trigonometric functions like sine and cosine, which are directly related to the circle and therefore to pi. For example, a sound wave can be written as this, where A is the amplitude, the strength of the signal, F is the frequency, how many cycles per second, T is the time, and phi is the phase shift, which in math means the horizontal shift of a wave over time. This phase shift can show a delay or advance in the heartbeat, or even help compare two heart signals. And what about your heart? Well, the heartbeat is a periodic signal with natural irregularities that can be measured as electrical waves. So, what does this mean? It means that even your heart, muscle, voice, or the vibration of your skin can all be described by equation where pi naturally appears. So, why not give Galileo some credit? Mathematics, a concept that might seem separate from us, abstract, maybe not that separate after all. But let's say with pi, which is not only found in circles, because it also appears somewhere you won't expect. Chance. To prove this, let's talk about prime numbers. Any whole number can be written as the product of other numbers. For example, 12 is the product of 3 and 4. 100 is the product of 4 and 2, 5. 40 is the product of 3, 2, and 1, 5. If you look at pairs of numbers, some share common factors, like 140, both have 2 and 5. Others don't, like 11 and 12, which share nothing. When two numbers share no common factors except one, we say they are coprime or prime to each other. In probability, when you pick two numbers at random, it is actually more likely that they are coprime than not. Try rolling many dice and you will see. You get coprime pairs more often than not. This probability can be calculated, and guess what? It is linked to pi. What does this look like in practice? If you roll a million pairs of numbers, about 607,718 of those pairs will be coprime. And using this, you get an approximation of pi. Pi is everywhere, from collision system in physics to games like the Syracuse conjecture and the game of life to construction like the pyramids. But there is more. Pi is also part of one of the most beautiful and famous formula in mathematics. This one. This formula connects geometry and arithmetic as well as five fundamental constants in math: 0, 1, p, e, and I, and three main operations: addition, multiplication, and exponentiation. There are many ways to prove it, but the simple one uses complex numbers. We all know that in trigonometry, cosine of pi equals -1, and sine of pi equals 0. And if you get exponential of I, x equals cosine x plus a plus I sin x. If you replace x with pi, we get exponential of e pi equals cosine pi plus e sin pi equals -1. So finally, exponential e pi plus 1 equals 0. Euler identity is an equation that connects five worlds in mathematics along one beautiful line. But let's keep talking about pi, if you don't mind. You probably notice after the 2, the decimals of pi go on infinitely without ever repeating. Unlike number like 1/3 or 1/7, pi has no repeating pattern. It's an irrational and transcendental number. Its decimal seems random, but on the opposite side, there are a number of sequences that can be predicted because they follow a precise logic. For example, if you define a sequence by this, we get this sequence of numbers 7, 21, 63, 189, where each term is deduced from the previous one by multiplying it by 3. This is called a recurrence sequence, and more specifically here, a geometric sequence. But how does this all relate to the real world? Let's take a famous example, Fibonacci's rabbits. Here is the question Fibonacci asked himself in the 13th century. How many pairs of rabbits will we have after 1 year if each adult pair gives birth to a new pair every month? A pair becomes adult after 1 month and no pair ever dies. So the first month there is one initial pair. The next month the pair is adult and the following month it produces a new pair making 2 pairs of rabbits and so on. The reasoning gives the following sequence: 1, 1, 2, 3, 5, 8, 13, 21, 24, 55, where each term is the sum of the two previous ones. This is called the Fibonacci sequence. And that's not all. If you take the ratio between two consecutive terms, for example, and let it tend to infinity, you get a number that is closer and closer to a fixed value. This one. This number is the golden ratio, and it's found everywhere in art, nature, architecture, music, finance, growth, or evolution models. From the spiral of the seashells to the arrangement of flower petals to the proportion of the great temples, the golden ratio fascinates. So, starting from a simple mathematical model of a rabbit population, we discover a harmonious proportion found all over the real world. And this link between the abstract world of ideas and physical reality was already found among the Greek philosophers. Let's talk about Parmenides, a philosopher not as well known today as Socrates, but who, unlike him, at least left his thought in written form, a philosophical poem to be precise. Parmenides was a pre-Socratic philosopher and one of the most mysterious thinkers of antiquity. Indeed, he was among the first to propose a philosophy based solely on pure logic, opposing the experience of the senses. For him, there is only one possible reality, unique, eternal, and immobile. Everything we see, change, movement, birth, death, is just illusion. His reasoning is radical. What is, what is not. Therefore, nothing can come from nothingness. Nothing can pass into nothingness. Change is thus impossible. The world is one, full and motionless. Only reason can reach this truth. The senses deceive us. There are only two paths, the path of truth, through reason, or the path of opinion, through the senses. This radical thought influenced centuries of metaphysics up to Heidegger, who regarded Parmenides as the fundamental thinker of being. But we are far from finished, because if strong philosophical ideas interest you, let me tell you about Spinoza, who for me is one of the most badass philosophers I have ever met. Imagine that his ideas were so disturbing that one day a fanatic tried to stab him. The blow was deflected by his coat, leaving a slash in the fabric. Spinoza kept that cool all his life as a reminder of the event and proof of the hostility toward his philosophy. And that was not the first attack on his ideas. At just 24 years old, he was excommunicated from his Jewish community in Amsterdam. He then lived modestly, alone, surviving on odd jobs, and philosophically revolutionary. But if Spinoza is for me one of the greatest philosophers the earth has ever born, it is especially because of his thought monism. Through monism, Spinoza rejects the image of a transcendent personal God external to the world. He states, Deus siva natura, God that is nature. For him, there is only one substance in the universe. This substance is God, or nature itself, if you want. God wants nothing, judges nothing, does not think like a human because he has no will of his own. He is simply the author and necessity of the world. And man, he is neither the center nor the chosen one. He is just an expression of nature, like everything else that exists. For Spinoza, there is no absolute free will. Everything that exists necessarily, but that does not mean everything is meaningless, because understanding the laws of nature allows one to reach a form of inner freedom. This freedom equals blessedness, an active joy born from understanding the world. And this vision of the unity of the world is not isolated. It is also found in Chinese Taoism, Buddhist practices Samudpada, Native American shamanism, and certain African or oceanic monotheism. Chance, what do you think it is? Since the old times, the ancient distinguished between phenomena that seems to obey harmonious laws established once and for all, and those they attributed to chance. Those they could not predict because they defied all law. Afterward, when you think about it, how can we speak of a law of chance if chance itself seems to be the antithesis of law? In every field, precise laws did not decide everything. They only mark the boundaries within which chance was allowed to move. In this conception, the word chance has a precise objective meaning. What was chance for one was also chance for other, and then for the gods. Well, perhaps not for all gods, because mathematics managed to capture this mystery and make chance graspable. How? Thanks to the laws of probability. So, what exactly is a law of probability? A probability law simply defines the measure of the likelihood that a chance-dependent event will or will not occur, expressed by 0 if the event is impossible and by 1 if it's certain to happen. Using the law of probability, it is possible to quantify the chance that a random event will occur. For example, when rolling a fair die, each face has a 1 in 6 chance of landing in face up. Of course, this doesn't allow you to predict the result of a single roll, but on a large scale an order emerges, which is what the law of large numbers show. If you flip a coin 10 times, you might gain 8 heads or even pair heads in the row. But if you flip it a million times, the result may tend toward 50% head and 50% tail. Chess is not the enemy of order. On a small scale, it is unpredictable, but on a large scale, it becomes regular. Even more, if you sum many independent random variables, their average follows a well-known curve, the normal distribution or bell curve, under which chaos seems to cluster. What seems chaotic at a small scale draws a harmonious shape on a larger scale. Chance, therefore, is not the opposite of order. It is its raw material, but does it end there? Not so sure. If you follow Spinoza thinking, for example, chance is an illusion. In itself, we call chance what which we do not know the causes of. In reality, everything that happens is necessary and follows a logical sequence, even if you do not understand it. And if this determinism does not stop at mathematics, it also applies to human beings. Your taste, your ideas, whether you vote Republican or Democrat, your career, your lifestyle are influenced by your environment. Growing up in a wealthy or poor neighborhood changes your chance of education, health, success, and completely reshuffle your cards. You don't think we choose freely, but often we just reproduce what our environment has instilled in us, our values, our morals, what you think, you have heard it, what you believe was transmitted to you. Society shapes our choice like gravity shapes the movement of the stars. Every phenomenon, no matter how small as it goes, and an infinitely powerful mind, infinite when informed about the laws of nature, could have predicted it from the beginning of time. And I guess at this point you finally get the message. What? You still don't understand? Okay, wait. I will try again, but this time it will be quicker. So we are at an unknown time in an unknown place. We are in nothingness before nothingness. And nothingness does not know it yet, but it's about to become. In a tiny fraction of a second, our nothing begins to exist. It swells extraordinarily. Elementary particles smaller than atoms appear. Electrons, protons, neutrons, and photons. This is the beginning of our universe. Over the next 3 minutes, the universe continues to expand and consequently to cool. The first atomic nuclei, mainly helium, formed by a combination of protons and neutrons. Then a great flash. 380,000 years after the Big Bang, the temperature of the universe drops below 2000 degrees Celsius. The conditions are then required for the first atoms to appear, hydrogen and helium. Electrons slow down enough to bind with atomic nuclei. This is the appearance of matter as we know it. As for the photons, until then trapped in this cosmic soup, they can finally move freely. The universe lights up, but this flash is short-lived. The universe becomes dark again because stars and galaxies do not yet exist. The first stars will not eclipse until millions of years later. The force of gravitation attraction, which pull all bodies together, gradually shapes the structure of the universe. Stars group into galaxies, which group into clusters, and even superclusters of galaxies. In their core, fusion reaction create new atoms, nitrogen, carbon, iron, and then it's the end for them. The formation of iron marks the final stage of their lives because they no longer produce enough energy to sustain themselves. They collapse and explode in supernovae. This explosion ejects elements like iron, nickel, and aluminum into space. These stars debris enrich nebulae, clouds of gas and dust, which under gravity gather, merge, and give birth to long stars, including our sun. Then, through collision and clumping, planetesimal form and grow until they become planets, including Earth. At first, our planet is young and fiery, so hot that it attracts wandering asteroids that crash violently on it before melting from the heat. The earlier Earth then emits volcanic gases, but no free oxygen yet. As the Earth cools, water vapor and gases condense, causing torrential rain for millions of years until ocean fall. Around 3.5 billion years ago, cyanobacteria, harnessing the immense energy of our sun, begin photosynthesis, releasing oxygen that first accumulates in the ocean, then in the atmosphere. In the ocean, small molecules begin to form and replicate, driven by hydrothermal vents on the ocean floor. Thus are born the first living beings, prokaryotes, simple bacteria without a nucleus, which later will evolve into eukaryotes possessing a nucleus. These bacteria organize and cluster, giving rise to animal and plant diversity, forming a chain on which humans will eventually rise to the top. From the death of the stars, the element came to compose our bodies, integrated to the earth during its formation, incorporated into the first living organism, then assimilated by our bodies through the food chain. Iron, for example, became the core of our hemoglobin, the molecule that allows us to bind oxygen and thus breathe. Thus, once born, man gradually came to dominate his environment. But looking up at the sky, he began to ask questions about his origin, about what he is, about where he came from. He quickly understood that he was just a tiny point in this huge universe, and left facing the uncertainty of existence. He was offered gods, stories to explain his origins, but beyond the gods, others escaped, seeking the truth within their soul, their conscience, their science. From ancient Greece to the fall of the Berlin Wall, same question answer us: how does our universe work? And why did we appear here? What is our purpose? Are we here by chance? Chance. Would this word explain everything? By the way, do you know why you clicked on this video? Is it a product of chance, the result of an independent action, maybe the YouTube algorithm? Since its origin, chance has thus been linked to play. And what if that was life's purpose? A huge game? And what if that was life's purpose? A huge game. Maybe that's true here as well. Maybe I've only been playing with you from the start, or whether am I here to learn from you? You know, I'm very interested in the gaps in knowledge that win for us as human beings and as a civilization. In the face of the challenges ahead, and one of those gaps concerns a very simple concept, which we all know. everything is connected. Everything is connected. Yes, okay. Many of you have already thought about this. After all, this concept is very close of that to causality is not unfamiliar to us. Causes lead to consequences, which in turn lead to other causes, and so on. We have all reflected on this before, not always fully understanding it. For many, this notion is seen as something abstract, esoteric, and improvable. And yet, our hearts are all beating right now. And the reason our heart beats is that we must transport oxygen to our blood with the help of a molecule called hemoglobin. Hemoglobin carries an even smaller molecule called Hb, and at the heart of the Hb lies a single atom of iron. And do you know how iron is created in the universe? Well, yes, right in the cores of stars. At the start, the universe contained almost no iron, only hydrogen or helium. And it was only through the life cycle of stars, their formation and explosion, that iron could be created. That same iron that flows through each of our veins. But the story does not end there. Why do stars keep forming? There are several ways for the star to be born, but one of the most spectacular is galactic collisions. This is when two galaxies crash into each other, their interstellar gases merge, and in doing so, they ignite, giving birth to countless new stars. Imagine each of those points of light you see in the sky represent the galaxy, and those streaks of light we observe are not galaxies themselves, but the path they will follow over billions of years. In this magnificent gravitational dance, galaxies whirl together, collide, and trigger massive star formation. Star formation that lead to the creation of iron. Iron that would beat in each of our veins with every heartbeat. Thus, in a way, each of our heartbeats is connected. Taking a deep breath is one of the simplest ways to reconnect with your own body. A slow, deep breath calming. But 3 billion years ago on Earth, taking a deep breath would have been impossible because there was almost no oxygen, so breathing would have been pointless. At this time, the Earth was almost an hostile place where only a few unicellular organisms could survive, hidden inside traumatoliths or other microscopic refuges. Do you remember our little bacteria? Yes. Fortunately for us, one of them was a cyanobacterium, an organism with an extraordinary ability, photosynthesis. That is, the capacity to absorb the sun's energy and transform carbon dioxide coming mainly from volcanic vents and producing oxygen. Starting about 2.5 billion years ago, this bacteria gradually spread across the planet, progressively converting all the carbon dioxide in the air into the oxygen we breathe today. The process was very slow. First, they had to saturate the ocean with oxygen. They saturate everything the earth could absorb, and only then afterward could oxygen begin to accumulate in the atmosphere. Thus, about 900 million years ago, the Earth's atmosphere finally began to become enriched with oxygen. And about 600 million years ago, an incredible event occurred, the formation of the ozone layer from this newly released oxygen. This may seem trivial, but before its appearance, the Earth could not really sustain complex multicellular life. We even have some unicellular organisms and a few rare, simple multicellular forms, but nothing that can resemble you or me. Shortly after the ozone layer formed, Earth could support complex multicellular life form. Life in the ocean exploded, and soon the first plant appeared on land. Nothing we know today could have existed without the contribution of those teeny organisms acting for billions of years. And where are they now? In fact, they never left us. The direct descendants of cyanobacteria were captured by plants. We now call them chloroplasts. Over the earth, billions of teeny chloroplasts continue to work locked inside plant cells, capturing sunlight, producing energy, and generating the oxygen that makes up the other half of our lungs. In this way, our breath are intimately linked. Every exhale we produce feeds the inspiration of a plant, and every exhale of a plant feeds our inspiration. Now, imagine for a moment that you were one of those tiny organisms 2 billion years ago. You would have been born, lived a few weeks, then died, convinced that nothing had changed. You will tell yourself, I had no purpose on this life. The world I came into is exactly the same as the one I left. But you will be wrong, because what you will not understand is that every breath you took contributed to the possibility of countless lives after you, lives you will never see, but of which we are all a part today. Perhaps we should think that the meaning of our lives goes with the age of our understanding, and if that were true for each of those organisms, maybe it's also true for us. This is a piano, and it is one of the most nuanced textured complex instruments. Thanks to it, brilliant musicians have created magnificent works. Some have even made it their profession, devoted their entire life to this instrument. Professional pianists learn to know it intimately. If you observe the brain of a pianist, using modern imaging techniques, you discover something fascinating. A large part of their brain activity is dedicated to this instrument. The control of the pedals, the fine perception of sound, the understanding of musical theory. All this translates into precise neural patterns, mental structures built over years of practice. And yes, just 200 years ago, this pattern did not exist because the piano was only invented in the 18th century. 5,000 years ago, Such a relationship with this instrument was unthinkable. The invention of the piano did not come from nowhere.
It required advanced knowledge in mechanical engineering.
The history and evolution of string instrument and a whole set of thought structures developed over time that allowed this object to come into being. And this brings us to another concept, the diversity of being. We are born into a world that offers us the experience, knowledge, and mode of thinking accumulated by humanity before us. If the piano and the way to play it is a mode of being, then it is a mode of being that did not exist for humans 5,000 years ago. It was a color on the palette of being that could not be painted with. Today, if you come into the world, you can acquire that color. You can learn to become a computer scientist, a shade that did not exist just 200 years ago. We are born into a world that already offers us ready-made colors. We can compose our unique painting from the palette around us at the moment of our birth. But through our lives, we also have the possibility to create a new color. It comes from inventing something, a self-driving car, a piano, a computer. It can come from the way you express yourself as a human being, from a work of art you create, from any form of existence that you bring into the world. Every new color we had enriched the palette available to those who will come after us. And this brings me to the very same thought. We live in a vast universe, which we often consider distant and indifferent. Inside this universe, there is a planet, Earth. Inside it, the biosphere. Inside the biosphere, society. And inside it, us. Every part of us represents one single person among 1.7 billion. So, how could any of us possibly matter? We often see the world as a container content system where everything valuable comes from the outside toward the inside, and we at the center have nothing truly special. But the palette of being tells a different story. It says that the way we live our lives, the way we influence our friends, our loved ones, change the way they will be able to paint a turn. And this influence spreads from individuals to communities, from communities to society, from society to the biosphere, from the biosphere to the physical planet, and from the planet to the universe itself. If tiny bacteria were able to transform the Earth's atmosphere and climate, then we too can transform our world. One essential question remains, how will we do it? For that, we have been given an extraordinary gift, consciousness. Thanks to it, we can understand how we are all connected in a unique way within the realm of life. And because we understand it, it is up to us to decide how to use this knowledge, how to shape our societies and our lives. In fact, all spiritual traditions affirm that we are all connected within. There is no accident. The societies that truly embody this idea are those that over time deepen their level of consideration, expression, and mutual understanding. That is why this idea returns tirelessly to the heart of spirituality. And as science shows today, it is not just a symbol, it's literally true at all levels of organization in the universe. And now, do you finally understand what I really wanted to go with this? No?
See nothing? That's normal.
Because for the very beginning, this video was not for you.